So one of the styles of questions that they're beginning to add to the SAT is this idea that for quadratic equations, that you need to be able to interpret the discriminant, and which is not anything that we emphasize here during our math curriculum. And so in this problem, if you know that the equation has no real solution, b squared minus 4ac, which is the discriminant, can be one of three things, right? If it's equal to 0, then there's one solution. If it is greater than 0, then there's two solutions. And if it's less than 0, then there's no solutions. Okay, so again, this is the discriminant. When you write your equation in standard form and then plug in b squared minus 4ac. Okay, so in this particular problem right here, if we take this equation and we evaluate the discriminant, and because it has no real solutions, we set it less than 0. So we get b squared minus 4 times a is 3, c is 5, and again, because we want no solutions, we want it to be a negative value. Okay? Again, the discriminant is the part of the quadratic formula that's in the radical, in the square root. So if it's a negative value, it does not exist. And so now if you solve this, b squared, here you get 5 and 4 is 20 times 3 is 60. And if we solve this, add 60 to both sides, there is the answer for this problem. Okay, again, this is something that is coming up if you take the SAT next spring. Okay, or later, you will very likely see a question that involves one of these three concepts. Okay, the one like this spring or next fall could go either way as they're trying to build the collections for later questions. All right, so that's the last of the Algebra 2 concepts that we are covering here. The last section that we're going to be able or have time to cover is a section that represents nearly half of the calculator portion. And it's about 45% of the questions all have to do with what they call data analysis, but it's just interpreting different types of graphs or charts of data. And so we're going to look at a few of those here really quickly. Some of them that will go so a lot of these questions are ones that you can answer very quickly without a lot of calculating. And so I want you to give your best shot here, A, B, C, or D, which of these expresses a strong negative association between D and T. D is the horizontal component, T is the vertical component. Okay, and patterns of data are going to have the following sort of properties. So here, if you see, this is a wide channel. A wide channel means it's a weak correlation. Okay, and the slope is basically the slope is basically determining positive correlation or negative. Okay, so if the slope is positive, or negative, then the correlation will be the same. And so this one has a wide channel in the negative going down as a slope, so that's a weak negative correlation. Here you have a narrow channel. Narrow channel is going to equal strong correlation, and here it's a positive slope. So that one's strong positive. Here we have a negative channel, or a negative and narrow channel. So this is going to be strong and negative. That's the one that we're looking for. Here it's just a relatively flat graph. Narrow or wide. Flat means relatively no correlation. Okay. So those would be the types that you might be looking at when it comes to just the tendencies of the graphs. All right. Again, I'm going through a lot of these questions because they're ones that you should be able to answer very, very quickly. Okay, so I want you to see, can you determine what's the minimum value of the function here between -4 and -6? And so basically what you're looking to decide is, are they asking for the x-coordinate or the y-coordinate, the inputs or the outputs? So when it says the minimum value, it's looking for an output or a y value. So if we look, the lowest y value is right here, and that corresponds to the y coordinate of -2. Okay. The lowest x value, the inputs would be at what value is the minimum, or at what value is the minimum of this graph, then that would be the x coordinate. All right. Interpreting data from different types of representations. It includes a table. It also includes probability. Again, there's a strong likelihood that you're going to have a question about probability or percents. And so I want you to see, can you read this information and determine what you need to answer. When you're finding the probability, you're looking at the number of desired outcomes over the number of all possible outcomes for what the probability is trying to measure. Probability is going to be a value between 0 and 1, and it corresponds to a percentage. So 0 means 0%, 1 means 100% chance that it'll happen. And so 0.3 means a 30% chance. Okay, so here, and probability can also be expressed as a fraction instead of a decimal, but somewhere between 0 and 1. Okay, oops, and it can equal those. Okay, so here when you're looking, you scan your answer choices. Again, nothing really demonstrated by that other than you know you have to find a fractional form. And then if we look up here to see what this data is telling us, it says if one of the houses, so that's all possible outcomes, is chosen, what's the probability that it's single story and slate roof? So single story here with a slate roof, there's a total of 4 of those. And the all possible homes is down here, 48. And so that would represent your probability. And it's not simplified here. More than likely it will be a simplified form when you look at the SAT version. He is not here yet, sorry. I have not seen him. All right. So let's jump to number 5 here. This is on page 21. Okay, I want you to do your best on this question. Histograms are concepts that I don't ever really recall going over with any students, even when I taught Algebra 1. I mean, that one would be the only possible place where you might see these. Okay, but I want you to see if you can answer this first, and then I'll talk through and give you some information about what it is and what you need to be able to do with it. Okay, so a histogram is basically like a bar graph, right? You see the bar graph right underneath it here. The only difference is the histogram has a range of answers. So there's no way to know specifically what the values are. So here what we see in this region right here that I highlighted in red, we don't know if those pyramids are 15 or 30, but there's 2 of them that are somewhere in that range. And so there's no way that you can actually calculate means or averages in a histogram. But what you can do is you can use sort of the tendencies and order of these. And so you can find a median. So if you have mean, median, and mode are the main central tendencies that are measured. Mean is the average. You add up everything, divide by the number of things that appear. The median is the middle term. When all the values are ranked. So if you rank from least to greatest, the median is the very middle value. If it happens to be an even number of objects being calculated, then the median is the average of the middle 2. And then the mode is the one that appears the most frequently. And there has to be a repeated value for a mode to even exist. And so if there is no repeated value, then there is no mode. Right, so when we look at this, and it's asking us here, which of these could be the median? For finding medians, a lot of times what you're going to do is you're just going to count your way from the outside in. Okay, so since median is the middle value ranked here, we can cancel these two values in red because those are the lowest two. We can cancel with these two here. And if we just sort of build our way in, so here we can cancel these three values with the next three, which would be this set, right? Those are the three highest, cancel with the three lowest. And as we continue to kind of work our way in, we now have these four next highest ones are going to cancel somewhere around here with four of these. Now, we don't know exactly where they're going to fall, right, between 45 and 60, but they're going to cancel somewhere in there. And so what we know then is that the median has to fall within this possible set of values. So again, we don't know exactly what it is, but we know it's going to fall somewhere between 45 and 60. And so the only option that falls between 45 and 60 is the answer 48. Okay, so again, when you're given something like this, you're not asking for specifics necessarily. You're asking for a range of possibilities. All right, let's jump to 7. Again, if you have any questions on anything, please feel free to ask. Okay, so one of the other types of data that you need to be able to interpret is scatter plots. We've seen this in some of the other examples, but I want you to see if you can answer this question. And again, this is in the calculator portion, so you will be able to use your calculators, although, again, most of these interpreting data types of questions are done without a calculator, which is why they're in the calculator section. Okay, so you don't really have a chance to use the calculator to an advantage. But I do strongly recommend, if you have a TI-89, take it. It's the most powerful calculator you can use on the SAT. And you cannot use the TI-89 on the ACT. So again, take advantage of it on the SAT. When you're looking at this problem, the first thing to notice here, if you scan your answer choices, is that you have a slope of either 0.21 or 0.43 and a y-intercept of either 32 or 62. Okay, so you can actually identify, you can reduce the number of options here just by looking at this graph. Okay, notice right here, this the point where this graph intersects the left edge of, or the left edge of the coordinates is approximately 62, right? So can that be the y-intercept if the x's aren't 0, they're 140? No. So you know for sure that C and D can't work, right? You see how that's kind of tricky? Like a student might look at that and say, the y-intercept is 62. I can see it right here. But this is not the y-intercept. This is just the point when x is 140. Okay? So the next thing to do is to determine which of these two equations is going to be your answer. Now, you can do one of two things. You can find 2 points or estimate 2 points on the line of best fit. Again, we're not using the data points. We're using the line of best fit here. And you can find the slope of those lines, or the slope of the line between those 2 points. But really, when I look at this, there is really just one point that I know with like pretty high certainty what the coordinates are. So I know this is the coordinate 320 for my x and 100 for my y. So rather than trying to find another point that's somewhere close, like this point right here is somewhere close, this point right here, we can use 180 and 70. I mean, those are the 2 points if I was going to calculate the slope. That's what I would use. But to me, the easier thing to do is to go ahead and just plug these two values, 320 and 100, 320 and 100, into the two equations and see which one's true. Right? So is it true that 100 is equal to 0.21 times 320 plus 32? Or is it true that 100 is equal to 0.43 times 320 plus 32? So I'm going to test those, and it just needs to be close, right? It may or may not be exact here. But if I take the 0.21 times 320 and then add 32, do I get a number that's pretty close to 100? Yeah. So I know that that's my answer. If I wanted to confirm that, if I took 0.43 times 320 plus 32, if that was the one that you tested first, you'd see that that's nowhere near what you were expecting, which was approximately 100. So that would be sort of the methods for testing that scatter plot. All right, I had also mentioned that one of the types of questions we looked at one like this that has shown up a bunch over the last couple years is a problem where you're interpreting the graphs and it's giving you a different ways of asking basically how many points fall above or below the line. So see if you can answer this again on same page 22. Can you figure out whether it's asking you to count the points above or count the points below? Okay, when you look at this perspective here, it's asking of these 10 airports, for how many of them were the delayed arrivals less than predicted? Okay, so that means that we're looking for what? Are we looking for points that are below the line, or are we looking for a line that's below the points? We want the points that are less than the predicted line, so that means we're looking for the points that fall below. So if we count those points that fall below, we get our answer, which here would be 6. Okay, let's look at the very next question. The very next question on the next page. Okay, it asks the same thing, but in a slightly different way. So see, how would you answer that one? This one is asking for how many of the data points is the y value that's predicted by the line greater than the actual y value. So this is another way of saying the exact same thing, right? We're looking for points that fall below the line. So this one, though, is saying where is the line greater than? That still means we want the points that fall below. Okay, so they can use some different wording to indicate this. Just make sure you're reading it carefully and identifying what are they asking for. So here, 1, 2, 3, 4, 5 points that fall below, and that would be your solution. All right. I do want to look at the next one. So just like with histograms, we really don't talk much about this what's called a box and whisker plot. And so the box represents quartiles, which you don't even really need to know for the SAT. The whiskers represent the range of possible answers. So that's one thing that might be asked. So here you know that in data set A, the range is from 10 to 140. And from data set B, the range is from 80 to 160. So that's one piece of information that you need to know from this type of data set, the data representation. The other thing that is often used in here is this little bar that exists inside those quartiles is where the median is located. And so that's the other thing that would likely be needed for this. Okay, so this represents a median. So if you want the range of the combined set, the lowest value is 10, the highest value is 160. So that means there's a range of 150. Just take the difference. Now the other type of question that might be asked given that same set of data would be something like which of these data sets has the higher or lower median? Okay, so the median of B is higher than the median of A. You can tell from where those vertical lines are inside the box part of that. All right. This next problem here I want to talk through first, okay, and then I'll have you try some questions that follow that are similar to it. Okay, one of the other types of questions, or one of the other more common types of questions that's contained in this section is problems where you're asked to convert out of different units. Okay, so this is a unit conversion type of problem, or a rate problem, and you will know it's a rate problem when you see things that have, again, a rate is a ratio of different units. So 60 minutes to 1 hour is a rate. Okay? 365 days to 1 year is a rate. So when you look here, this is a rate. So anything where it's something per something else, miles per hour, is a rate. So when we look here and we start to see this, we have this millibars per hour. There's a rate. We have, it looks like that's the rate that's provided. And then you have this given rate here. Anytime you recognize that it's a unit conversion type of problem, the SAT is really consistent with this, and they brought these types of questions back. These used to exist before 2016, and they brought them back the last couple of years. So again, there's a strong likelihood that you'll see some questions like this. And it's very consistent, and it always has been. The way that you approach these problems is you take, once you recognize its unit conversion, take the very last piece of information you can see in the problem, 5 hours, and we begin with that. And you just start converting out of those units based on the conversion factors that you have. So in order to convert out of hours, what we see is that there's 3.4 millibars per hour. So for hours to cancel, hour needs to be in the denominator, which means the 3.4 millibars is in the numerator. So we've converted out of hours. We want to get into this millimeters of mercury as our solution, so we need to convert out of millibars. Well, we have this next conversion right here, where there's 1,013 millibars per 300 or 760 millimeters mercury. And so we need to put the millibars in the denominator so those units cancel. So it's just a matter of organizing units and then converting. So this is in the calculator section, and this would be one of those sort of a little bit more rare examples of you do need to use a calculator for this. So if I take my 5 hours times 3.4 and then times 760 and then divide by 1,013. Now my calculator's set up that since I've entered a decimal, my answer will display as a decimal. If I want to force a decimal on the TI-89, I can use the green diamond button, and then my answer will be written as a decimal no matter what. So I get 12.75 approximately for my solution, which means the answer is option B. All right, I want you to try the next problem here. This one is as difficult as it gets for the unit conversion. Okay, so if you struggle on this, don't worry. We'll do one more after this. This would be about as hard as it gets as far as doing some extra stuff to interpret what or how to convert out of the original units. But again, once you recognize that there's a unit conversion, just start with the very last piece of information and then work to get rid of or to convert out of that unit and into the desired one. All right. So when you sort of recognize you have this unit conversion here, and you see that you are looking at 2 kilometers per hour, your answer is going to be a rate. Okay, so you know you're dealing with this unit conversion. So if we begin with the very last piece of information, 779 revolutions per minute, so over 1 minute, right? So here's what we start with. So we're going to begin with the very last piece of information. And now we want to convert out of that and into kilometers per hour. So let's do the time first. Time is a little bit easier to convert. So we convert out of minutes because 60 minutes is equivalent to 1 hour. So we've converted out of that unit. And we now need to convert in the distance into kilometers. Well, we don't know any distance here. We just know the revolutions. Okay? But revolutions around a tire, what is 1 revolution equivalent to on a tire? What is that called? What's this distance covered here? 1 revolution is a circumference, right? Which calculation-wise is d pi or 2 pi r. And so since we know the radius of that tire, what we can do is we can plug that in 2 pi times 0.3. So that gives you 0.6 pi. So this is the equivalent of 1 revolution. So that's what makes this challenging, is they don't just give it to you. You actually have to know how that works. So 1 revolution, so that will be written on the denominator, so it cancels, is equal to 0.6 pi, and the units are meters. Again, it's all about managing your units here. And then the final thing is to convert out of meters and into kilometers. So we use the 1,000 meters is equivalent to 1 kilometer, so that our unit of meters cancel. Right, and so here is our calculation. Once again, this is the calculator portion. Right, and so we can use the calculator here to find this. And if we multiply through, make sure you know where the pi button is on your calculator if you're using a TI-89, and then divide by 1,000. I've entered my answer with a decimal, or entered my entry has a decimal, so the answer is going to have a decimal for me. I get 88.1, and so it asks us to round this or to estimate, approximate, and so you get 88 as our answer for that. All right, so I want you to try number 14 and see if you can kind of follow that same process in one that's maybe a little bit more straightforward, but it follows the same pattern. So here you look at your answer choices. Right? That doesn't give you any additional information. So if we read our problem, we see 56 miles per hour. We see a rate of 31 miles per gallon. So these are 2 rates. Okay, so unit conversion is probably going to come into play here. Go to the last piece of information that's provided. And so we start with that, 5 hours, and now we just start to convert out of that unit. So the conversion we have for hours is that you have 56 miles per 1 hour. So 1 hour is equivalent to 56 miles. The units, hours, cancel. Now we want to cancel out of miles. We have this conversion here, that 31 miles is equivalent to 1 gallon. So notice the miles go in the denominator so that they cancel as well. Our answer is looking to find gallons, so we have the unit that we're looking for. And so it's just a matter now of calculating 5 times 56, divide by 31. Now, I didn't enter a decimal in my entry here, so I either need to, the way I have mine set up, enter a decimal. I get my answer to be 9.03, which means the solution is going to be 9, option D. All right, the last thing that we'll probably have time for here today is to look at the next concept that seems to exist an awful lot on the SAT, or very frequently, is this concept of percent, working with percentages. Okay? And so sometimes percents kind of corresponds to probability, but a lot of times it's in the sense that you're either having a discount on something or you're paying tax on something. And the biggest advantage, or the biggest strategy for using percents is to not think of something as being like if you're paying a 20% tax, okay, instead of saying it's the original price plus 20% of that price, just think directly in that it's 1 plus 20% of the original price. If you're looking at a discount, so let's say you have a discount of 20%, don't think of it as taking P minus 20%. Think of it, if you're reducing by 20%, then that means you're actually paying what percent of the whole thing? You're paying 80% of that whole thing. So notice these all directly lead to the same thing, but if you can just start with that quantity, it makes it easier to work with. So I'm going to talk through this first one, and then I'll have you try the second one on your own. So looking at question 15, we scan the answer choices. We can see that will likely potentially write our answer just as the calculation itself and not have to do the calculation. But here, if you're reading through and you see that this is a 20% discount off the original price, that means that you're paying 80% of that original price, right? Okay, and it says that the total amount was paid was P dollars, so P is going to equal 80% of whatever the original price was. Well, the original price included an 8% sales tax. So let's say that the original price was X. Okay, so this represents your original price. If you paid an 8% sales tax, that means that you add 8% to 100%, meaning that you pay 1.08 of that. So if you represent your percentages as being added in decimals or subtracted as decimals, it then gives you a more direct way to calculate, because here, if you want to find the original price, that means we're solving for X here. We divide by 0.8, we divide by 1.08 to cancel, and to cancel we get X is equal to, and that option is choice D. Okay, so working with the remaining percentages or combining the decimal forms of the percentages is going to be like the most successful strategy using percents. All right, so try this last question here, and then we'll wrap it up. All right, so we can see from scanning the answer choices that our answers are going to be kind of pretty close. And you can see that whatever it's testing the difference between 0.29 and 1.29, and it's testing the difference between 1.28 and 2.28. Okay, so let's kind of look and see what this represents. Okay, so if the number of phones sold was 128% greater, that means that it's 100 plus 128%. So in decimal form, that's 1 plus 1.28. So that means it's 2.28. Of whatever the original price was, or the original number was. Right, and then in 2015, that is, they sold 29% more than that. So this was 2015, or this was 2014. So 2015 is going to be all of that times 29% greater. Well, 29% greater is 1.29. Again, if we put that, add it, or combine it in the decimal form, we get 1.29 times whatever it was in 2014, which was this whole value. And so that means that in 2015, the calculation is option C. Okay, so working with remaining percentages or working with the decimal forms combined is sort of the key to that.